So let us have some introduction in the concept of average. Average. So take an example. Suppose 5 students, they got 15, 24, 11, 8 and 2 marks. So 15, 24, 11 and 8 and 2. These are the marks obtained by 5 students. Suppose, how to find out the average mark obtained by all the 5 students? So here in this case 15, 24, 11, 8 and 2, they are the individual marks. What is the total mark obtained by all the 5? 15 plus 24, 39, 39 plus 11, 50, 50 plus 8, 58, 58 plus 2, 60. So 5 students, they got 60 marks in total, right? But we have to find out the average mark. So 5 students, they got 60 marks in total, and if you distribute 60 marks equally among them, each student can get 12 marks. So that can be named as the average value. That can be considered as the average performance of the group. So here nobody got exactly equal to 12 marks. 15, 24, 11, 8 and 2, they are the individual marks obtained by students. But all the 5 students, they got 60 marks in total. Suppose if you distribute 60 marks equally among them, each student can get 12 marks. So that is the average value. So how to get the average of certain quantities? We have to divide the total of all the elements by the number of elements. So here the total of all the elements is 60 by the number of elements is 5. So therefore the average mark is equal to 12. So therefore what is the formula for average? Total by number of elements. That is the formula for average. So then we can design the second formula. If you shift this number to the left side of the equality, we can get a total is equal to number of elements into average. So I can place before you, total is equal to number of elements into average value. Total is equal to number of elements into average. So these are the two formulae. By making use of these two, we can do some problems. So how to get the average of the quantities? Total of all the elements by number of elements. In this case, the total mark obtained by all the candidates is 60 and the number of candidates is 5. So therefore what is the average mark? 12. But here what you have to observe is the average is obtained as 12, but it doesn't mean all the people can get exactly 12 marks each, right? So nobody got marks equal to 12, but the average mark of the class is equal to 12, right? Next, what is the second formula? Total is equal to number into average. And I give one more example. How to make use of the second formula? Suppose this is the data. The average salary of 8 employees in a group, that is 20,000 rupees per month. The average salary of 8 employees is 20,000. So in a group there are 8 employees and the average salary that is given as 20,000. Friends, what you have to observe is the salary of 8 employees is 20,000. The average salary of 8 employees is 20,000. It doesn't mean that the salary of each one is exactly 20,000. One may get 30,000, the other can get 10,000. But we are not particular about the salary of the individual. But there are 8 members in the group and their average salary that is given as 20,000. So let us make use of the second formula. Here the number of candidates is 8 and the average is 20,000. So number into average, that is equal to 1,60,000. That is the total salary of all the 8 employees. But we are not particular about the salary of the individual. So we are not particular about the salary of the individual. So here the number of participants is 8 and the average salary is 20,000. So number into average, 8 into 20,000. So 1,60,000, that is the total salary obtained by all the 8 people, but we are not particular about the salary of the individual. Next, one more example. The average age of 3 sisters, that is 10 years. The average age of 3 sisters is 10 years. So there are 3 sisters in the group and their average age is given as 10 years. But it doesn't mean the age of each one is exactly 10 years, right? So here the number of candidates is 3 and their average is 10. So number into average, that give the total age of all the 3 members together. The total age of all the 3 members together. So here we can get the total age of 3 candidates as 30, but we are not particular about the age of the individual. So this is the second formula, right? The first formula, that is average is equal to total by number of elements. Second formula, total is equal to number into average. Next, one more example. Suppose 15, 5, 19 and 1. So here I have given 4 elements, 15, 5, 19 and 1. Friends, what is the total for all these 4 elements? 15 plus 5, 20, 20 plus 19, 39, 39 plus 1, 40. So here the total is 40. And what is the number of elements in this group? 4. But as I said earlier, total, that is 40, number of elements is 4. So therefore we can calculate the average as total by number of elements, which is equal to 10. So there are 4 elements in this group and the average for these 4 elements is equal to total by number, which is 10. So let us observe one condition. Suppose each element is increased by 3. Each element is increased by 3, or in other words, let us add 3 to all the elements. So 15 plus 3, 18, 5 plus 3, 8, 19 plus 3, 22 and 1 plus 3, 4. Friends, what is the change affected to each element here? Each element is increased by 3. So 18, 8, 22 and 4, that will be the new set of elements, right? 18 plus 8, 26, 26 plus 22, 48, 48 plus 4, 52. So in this case the total changes to 52, but there is no change in number of elements 4. The formula for average is total by number of elements, 52 by 4. So therefore what is the new average? 13, right? Once again back to the example. What is the average for first 4 elements? It is 10. What is the change affected to each element? Each element is increased by 3. Then what will be the average of new set of elements? 13. So what you have to observe is each element is increased by 3. Each element is increased by 3. Then we can observe that the average also increases by same 3. No doubt the average changes from 10 to 13. The average changes from 10 to 13. So therefore the average also increases by same amount. And I will give one more example. Suppose 15, 5, 19 and 1, these are the 4 elements. Suppose each element is decreased by 2. Each element is decreased by 2. Then the average also decreases by 2. Suppose each element is multiplied by 3. Average also multiplied by 3. Suppose each element is divided by 4. Average also divided by 4. So at this level what you have to observe is, for a group of elements, what will be the number of elements? For a group of elements, what will be the number? If the same treatment is extended to all the elements, I repeat it, if the same treatment is extended to all the elements, we have to extend the same treatment to the average also. Suppose each element is increased by 3, average also increases by 3. Suppose each element is decreased by 2, average also decreases by 2. Suppose each element is multiplied by 3, average also multiplied by 3. And suppose each element is divided by 4, average also divided by 4. So this is the example what you have to remember. And the next one is, suppose we are given some elements and the average is given by total by number of elements. So here I want to give a group of elements 3, 7, 11, 15 and 19. So I have given 5 elements to you, 3, 7, 11, 15 and 19. So there are 5 elements. What is the total for all these 5 elements? 3 plus 7, 10, 10 plus 11, 21, 21 plus 15, 36, 36 plus 19, 55. So here the total is 55. What is the number of elements here? Here the number of elements is 5. Then what is the formula for average? Total by number. So here the total is 55 and the number of elements, that is 5. So therefore the average is equal to 11. So I have given a set of 5 elements and the total is 55 and there are 5 elements. So therefore average is obtained by using the formula total by number of elements. Total by number of elements. So what is the average obtained? 11. But some of you can observe that 3, 7, 11, 15, 19. For this set of elements we can observe the difference between successive elements is constant. The difference between successive elements is constant. The difference of these two, that is 4. The difference of these two, 4. The difference of these two, 4, like that. So here we can generalize a condition. If the difference between successive elements is constant, if the difference between successive elements is constant, then the average can be obtained by using the formula first element plus last element by 2. I repeat it. If the difference between successive elements is constant, if the difference between successive elements is constant, then their average can be given by using the formula first element plus last element by 2. Here the first element is 3, the last element is 19, first element plus last element 22 by 2. So therefore 11 is the average. So both are one and same. 11 is the average. So therefore the general formula to find out the average is total by number of elements. That is the general formula. But in this particular case, the difference between successive elements is constant. So if the difference between successive elements is constant, then the average can be obtained by using the formula first element plus last element by 2. So first element plus last element by 2, that is 11. Or you can observe this 11 is nothing but the middle element of the group. We can say 11 is the average. We can say the middle number is the average. But when can you find out the middle number? If the number of elements is 3, we can get the middle element. If the number of elements is 5, we can get the middle element. If the number of elements is 7, 9, 11, so in such a case we can find out the middle element. So once again we have to recollect it. What is the formula for average? Total by number of elements. That is a general formula that is applicable in all the cases. But when can we apply the formula first element plus last element by 2? If the difference between successive elements is constant, then we can apply the formula for average as first number plus last number by 2, or we can select the middle number as the average. Suppose this is the problem. What is the average of first 18 multiples of 5? This is the question. What is the average of, I am not interested in the first 18 elements, I am not interested in first 18 even numbers. What is the average of first 18 multiples of 5? We are interested in only the multiples of 5. You all know multiples of 5, that is 5 into 1, 5 into 2, 5 into 3, 5 into 4. So like that we are interested in 18 elements. These 18 elements must be the multiples of 5. So therefore the first element is 5, the second element is 10, the third element is 15, and the fourth element is 20. Then what will be the 18th element in that series? That is 5 into 18, or simply saying 90. So these are the 18 elements which are the multiples of 5. 5, 10, 15, 20, like that we have to take 18 elements. And of course the 18th element will be 5 into 18. And here we are interested in finding the average of these elements. What is our general formula for average? We have to take the total of all these elements by number of elements. But in this case it is not necessary to get the average, get the total, because all these elements they differ by 5. The difference between successive elements is 5. The difference between successive elements is 5. So as we discussed earlier, if the difference between successive elements is constant, then their average is given by first number plus last number by 2. Here the first number is 5 and the last number is 90. So first number plus last number 95 by 2. So 95 by 2, or you can take 47.5 as the average of first 18 multiples of 5, right? So here we are interested in only the multiples of 5, and they are 18 in number. So 5 is the first element, 10 is the second element, 15 is the third element, and like that 5 into 18, 90 is the last element. So no doubt the difference between successive elements is constant, and we can observe the average by using the formula first element plus last element by 2. And suppose this is the question: what is the average of first 13 multiples of 3? What is the average of first 13 multiples of 3? So here we are interested in only the multiples of 3. So how will be the multiples of 3? 3 into 1, 3 into 2, 3 into 3, 3 into 4. So like that 3 into 13. So 39 is the last element. So we have to consider 13 elements, and all these 13 elements must be multiples of 3, right? So 3 into 1, first number, 3 into 2, second number, 3 into 3, third number. So like that we have to consider 13 elements, 3 into 13. So here also it is not necessary to calculate the total and then divide with the number of elements, 13. So straight away we can apply the formula first element plus last element by 2, because the difference between successive numbers is constant 3. So here the first element is 3, the last element is 39, first element plus last element by 2. So 3 plus 39, that is equal to 42 by 2. Therefore what is the average for all these elements? 21. So in this concept we have to bring 3 concepts, right? The first one is the formula for average is total by number of elements. The formula for average is equal to total by number of elements. And the second formula, total is equal to number into average. Total is equal to number into average. Third one, in a group of elements, if each element is increased by 3, average also increases by 3. If each element is increased by 5, average also increases by 5. If each element is decreased by 2, average also decreases by 2. So like that. And the fourth point what you have to remember is, if the difference between successive elements is constant, if the difference between successive elements is constant, then the formula for average of elements is first number plus last number by 2. So these are the points what you have to remember for the purpose of all the competitive examinations. And here let us go through some more examples. The first one, in a school 60 boys, they made an average score of 55. There are 60 boys and they made an average score of 55, right? Next one, there are 40 girls, and they made an average score of 45. Girls average score, that is 45, girls average score, that is 45, and there are 40 girls in number. The average score of 60 boys is 55 and the average score of 40 girls is 45. And here the question is, what is the overall average score, right? Friends, let us recollect the formula. Number of elements into average, that give the total. Number into average, that give the total. Here 60 is the number of boys, they made an average score of 55. So 60 into 55, 3300. 3300, that is the total mark obtained by boys. Next, there are 40 girls and their average score is 45. Number into average, that give 1800. 60 into 55, 40 into 45. This is the total mark obtained by boys. This is the total mark obtained by girls. So therefore, what is the total mark obtained by all the 100 students together? 3300 plus 1800. So 5100, that is the total mark obtained by all the 100 students. 5100, that is the total mark obtained by all the 100 students. So therefore, what is the formula for average? Total mark obtained by all the students by number of students 100. Average is equal to total by number of elements. So therefore, in this example 51, that is the average mark obtained by all the students. So number into average, 5100, that is the total mark of all the 100 students. So average is equal to total by number. So therefore, what is the average mark obtained by all the 100 students? It is 51, right? Next, second example, which is mostly repeated in different competitive examinations. This is the average age of 30 girls in a class, that is 14 years. There are 30 girls in a class and their average age, that is given as 14 years. So here the number of students is 30 and their average age is 14, right? So the average age of 30 girls in a class is 14 years. Next sentence, if the age of the class teacher is included, the average become 15 years. And the question is, what is the age of the class teacher? Friends, there are two techniques available to attempt this problem. So I will give the first technique to you. The number of girls is 30 and their average is given as 14. So as we discussed earlier, number into average, that give the total. Total is equal to number into average. So here the number of girls is 30 and their average is 14. So this 30 into 14, 420 years, that is the total age of all the students together, right? Next, if the age of the class teacher is included, then the number of candidates will change to 31, right? So with the addition of the age of the class teacher, the average age become 15 years. So here 15, that is the average age of all the 31 candidates including the teacher, right? So therefore number into average, number of candidates 31 into average, so therefore 465, that is the total age of all the students and the teacher together. So once again, the number of students is 30 and their average is 14. So number into average, that give 420. That is the total age of all the students, 30 members. Next, if the age of the class teacher is included, definitely the number of candidates will become 31 and their average is given as 51. So number into average 465, that is the total age of all the candidates. But here we are interested in the age of the class teacher. Friends, what is the total of all the 31 candidates? That is 465. This 465 minus 420, that give the age of the class teacher as 45 years. This is the general technique available. This is the general method available. Out of the total 465 as the total of 31 members, if you delete the total for 30 members as 420, then we can get 45 years as the age of the class teacher. But there is another method, right? Let us observe the second procedure, which will be helpful to the average student. Here there are 30 members and their average is given as 14 years. So let us suppose each girl is of age 14 years, 14 years, 14 years and 14 years, so on. There are 30 girls. There are 30 girls whose average is 14. So let us imagine a group of 30 members who are exactly 14 years of age, 14, 14, 14, 14, 14, like that. Suppose a teacher of age 14 entered into the class. Let us observe, let us imagine a teacher of age 14 years enter the class. Then there will be no difference, there will be no variance in the average value, because the average age of all the students is 14. So each candidate is assumed with the age 14, 14, 14, 14, 14. Suppose a teacher of age 14 entered into the class, the average also remain the same 14. But in this case, the average is changed from 14 to 15. The average is changed from 14 to 15, right? So what is the number of candidates in the class? 30. And with the interference of the class teacher, the number become 31. But the average changes from 14 to 15. So here what you have to observe is, there is an increase by 1 year. There is an increase by 1 year at all the candidates. Now the number of candidates is 31. 30 students plus 1 teacher. So now the number of candidates is 31. If suppose the teacher is of age 14 years, then there will be no variance. If suppose the age of the teacher is 14, then there will be no change in the average. But with the interference of the teacher, the average now changes to 15. So therefore the average is increased from 14 to 15. We are going to observe an increase of 1 year. We are going to observe an increase of 1 year at all the candidates. So there is an increase by 1 year and there are 31 candidates, 31 into 1. So therefore we can observe an increase by 31 years. And now the question is, who contributed this increase? Who contributed this increase 31? No doubt that is contributed by the teacher. So therefore the teacher's age is 14 plus 31, that is equal to 45 years. I repeat it. There are 30 girls in the class and the average is 14. So let us suppose each girl is of age 14, 14, 14, 14, 14. Suppose imagine the class teacher of age 14. Then there will be no change in the average value, just it will be at par with the average of the students, which is 14. But with the interference of the class teacher, now the average changes from 14 to 15. So no doubt the average is increased by 1 year. So there is an increase by 1 year at all the 31 candidates. So 31 into 1. No doubt the total is increased by 31 years. Who contributed this increase? 31. Who contributed this increase? 31. That is contributed by the class teacher. So therefore The class teacher bought 14 plus 31. So therefore 45 years, that is the age of the class teacher. So this is the second technique available. Friends, you try to adopt your own technique which will be convenient to you, right? Next, another problem. The average age of 16 members in a company, that is given as 28 years 3 months. So there are 16 members in the group. The number of candidates is 16, but their average age, that is given as 28 years 3 months. It is not simply 28 years, it is 28 years 3 months. You all know that 3 months is equal to 1/4 of the year. 3 months, which is equal to 1/4 of the year. Here the average is given as 28 years 3 months, or 28 1/4, which is in the form of a mixed fraction. So therefore this is equal to 113/4. There are 16 candidates in the group and the average is given as 28 years 3 months, or in other words 28 1/4, which is equal to 113/4. So therefore the number of candidates is 16 and the average is 113/4. Next, two men of age 56 and 60 years, they left the group. And now the question is, what is the average age of the remaining members in the group? So in the first case, the number of candidates is 16 and their average is given as 28 years 3 months, or 28 1/4, which is equal to 113/4. Number into average, that give the total value. Number into average, that give the total value. So here 4 gets cancelled. So 113 into 4, 452 years, that is the total age of all the 16 members. So out of 16 members, 2 men of 56 and 60, they left the group, or in other words the total age must be reduced by 116. 56 plus 60, 2 men they left, so therefore the total decreases by 116. So here 336 years, that is the total age of the remaining 14 members, because out of 16 members 2 members left the group, so 14 is the current strength, right? So 336, that is the total age of 14 candidates. Then what is the formula for average? Total by number of candidates, and after suitable calculation we can get 24 years, that is the average age of the remaining members in the group, right? So 16 is the strength, number into average 452, that is the total, and out of 452 we can delete 56 as well as 60, because these 2 members they left the group. So 452 minus 116, that is equal to 336. 336 is the total for the remaining 14 candidates. So average is equal to total by number. So therefore 24 years, that is the average age of the remaining members in the group. Next one, the average of 13 observations or 13 elements, that is 68. Next sentence, the average of first 7, is 63 and the average of last 7 is 70, and the question is find the 7th observation. Friends, in this case, as per the first sentence, there are 13 elements. The average of 13 elements is 68. So here the number of elements is 13 and their average is given as 68. So number into average, number of elements 13, their average is 68. So number into average, that give the total value, which is 884. This 884 is the total for all the 13 elements, and out of 13 elements, the average for first 7, that is 63, and the average for last 7, that is 70, right? So number into average, 7 into 63, 441, that is a total for first 7 elements. Number into average, 7 into 70, 490. Friends, in this case what you have to observe is, as per the first sentence there are 13 elements, but these 13 elements they are divided into 2 subgroups, first 7, last 7, right? And if you go in detail, first 7 means 1, 2, 3, 4, 5, 6 and 7. These are the first 7 elements. Next, last 7 elements. As there are 13 elements, we are counting from the last one, 13th, 12th, 11th, 10th, 9th, 8th and 7th. These are the last 7 elements, right? Friends, again back to the calculation part. What is the average for first 7 elements? 63. So therefore total is 441. The average for last 7 elements is 70. The total is 490, right? So what you have to observe is, 7th element that is common to both the subgroups, first 7, last 7. We are getting 14 elements in total, but we are given only 13 elements. So why this first element, one element appear in excess? That is the 7th element which is common to both the subgroups, that appears twice. So that is the value of the 7th number what we require, right friends? What is the total for first 7 elements? 441. What is the total for last 7 elements? 490. The sum of these two, that is 931. 931, that is the total for all these elements written here. I repeat it. The average for first 7 is 63. Therefore the total is 441. The average for last 7 is 70. The total is 490, right? So if you add these two, this 931 is the total for all these elements written here. 931, that is the total for all these elements, and out of 931, if you eliminate these elements, we can get only the 7th number. So these elements mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Nothing but the 13 for all these elements. So what is the 13 for all? What is the total for all the 13 elements? That is 884. So once again I repeat, the total for first 7 is 441. The total for last 7 is 490. So what is the total for all these elements here? 931. And out of 931, if you eliminate these elements who are marked, that is 884. So 931 minus 884, that 47 is the value of the 7th number, which is common to both the subgroups. 931, that is the total for all these elements, and out of 931, if you eliminate these elements, that is 884, we can get 47 as the value of the 7th number, which is common to both the subgroups. So what finally you have to observe is, there are only 13 elements in the group, but these 13 elements are divided into 2 subgroups, first 7 and last 7. There you have been getting 14 elements. One element appear in excess, that is the 7th element. The value of that 7th element can be calculated as 47, right? And we can give one more example to you. The average of 11 numbers is 50. The average of 11 numbers is 50. Next, the average of first 6 numbers is 49, and the average of last 6 numbers is 52. The same concept as we did in the previous problem. In total there are 11 elements. There are 11 elements, but these 11 elements are divided into 2 subgroups, first 6 and last 6. And starting from the 11th element, if you go for last 6, these will be the last elements. First 6 elements, last 6 elements. We are getting total 12 elements, but only thing is we are given only 11 elements. So why this single element appear in excess? This sixth element is common to both of them, that appears in excess, right? And if you go for the detailed part of calculation, the average of 11 numbers is 50. So number into average, that is the total, and out of which the average of first 6 numbers is 49. Number into average, that is 294. The average of last 6 numbers is 52. So number into average, that is 312. So 6 into 49, 294. That is a total for all the 6 elements. 6 into 52, 312. That is a total for all these elements. So if you add these two, then this 606, that is the total for all the 12 elements written here. I repeat it. What is the total for first 6 elements? 294. What is the total for last 6 elements? 312. So 606, that is the total for all the 12 elements. And out of 12 elements, if you eliminate these elements who are strike off, that give the 6th element. So therefore 606, and you try to eliminate 550, then 56, that is the value of the 6th number, which is common to both the groups, right? Here what you have to observe is there are only 11 elements in the group, but they are divided into 2 subgroups, first 6, last 6. In total there are 12. So one element appear in excess, that is the 6th number, which is common to both the subgroups. The 6th element can be calculated as 56. So these two problems, they come under a single category. Next problem with a little variance, you can observe that the average of 11 numbers is 30. The average of 11 numbers is 30. The average of first 5 numbers is 28, and the average of last 5 numbers is 25. So here there are 11 elements in the data, but these 11 elements are divided into 2 subgroups, first 5, last 5, right? So if you observe 11 elements, so these are the 11 elements, and out of 11 elements there are 2 subgroups, first 5 and last 5. So what is the difference of this model and the previous one? In the previous model we had one element in excess, but here we are in sort of one element, because there are 11 elements in total, but they are divided into 2 subgroups, first 5, last 5. First 5, last 5 means we are getting only 10 elements. So here we are short of the number, that is the 6th number what you have to calculate, right? So if you go for a detailed calculation, the number of elements is 11 and their average is given as 30. So number into average, that gives the total value 330. Number into average, that gives the total value 330. Next, for first 5 elements, the average is given as 28. So number into average, that gives the total value 140. Number into average, that gives the total value 140. Next, for the last 5 elements, the average is 25. So number into average, that gives the total value